Okay, good afternoon.
Good afternoon.
Good afternoon.
Are we still in the Easter season? Happy Easter. That's if you are still in the Easter season. If not,
Thank
then
you, and
happy
same to you.
belated Easter. Hope we are all doing well, please.
Yes, hope you too.
We
By
thank
God's
God.
grace.
Okay. I see only 51 participants, but we'll start anyways because it's already 6 minutes. Can somebody pray for us?
Shall we pray?
So,
Wonderful Father, this afternoon, thank you also thank you for such opportunity like this. I pray and commit today and into your hands. We come back. Feel like there is no understanding. We thank you.
are you praying? Because we can't hear you, or you are done praying.
Oh, but you didn't hear me.
I we heard you from the beginning. Okay, I heard you from the beginning, but getting to the
Oh,
end,
okay.
I
Okay.
kind of
Okay,
lost
then
it.
let me start. Let me
But if
start
you are
again.
done praying, it's fine. Don't worry.
Oh, I can start again. Don't worry.
Oh, okay.
So shall we pray?
Yes, please.
Father, this afternoon, thank you once again. We thank you for such an opportunity for our life, our family, and also our lectures. Father, we pray and commit today class into your hands. May you come and give us the wisdom, understanding, and then at the end, we give you honor and glory. These are many things we ask through your Son, Jesus Christ. I pray. Amen.
Amen. Amen. Amen. Thank you very much. So before we start today's class, I was reading something and I would like to share briefly with you guys. I was reading something in Colossians 3, verse 17, and it says, whatever you do, no matter what it is, in word or deed, do everything in the name of the Lord Jesus and in dependence on Him. And my emphasis is on, or I want to emphasize on, no matter what it is. I'm reading from the Amplified Version. It says, no matter what it is. So I just want to encourage you guys this afternoon that no matter what it is, the things you think are minute, not necessary, not important, He's very interested in it. God is very interested in it, whether in words or in deed. So whatever it is that you are going through or working with or dealing with, and you think it's not necessary, just remember that He's very, very interested in that. Okay, so that's just by the way. So today we'll be looking at object modeling. I think our last lecture was it object-oriented programming? Or what was our last lecture?
Data flow.
Data flow. Oh, okay. So I think today we'll be looking at object-oriented program, probably something around that. But our topic is object modeling. And then we'll be demonstrating how object-oriented analysis can describe an information system. We'll be looking at what an object represents in an information system. And when we talk about objects, we need to know that there are definitely attributes, methods, messages, and then classes we need to consider when it comes to object-oriented and how it's embedded within systems. So we'll look at that in a nutshell today. So let's start with what object-oriented analysis is. It's termed as OO analysis, but the definition is object-oriented analysis. So it describes an information system by identifying things called objects. And what is an object? An object represents a real person, place, event, or transaction. So in GCTU, for instance, we can say a student is an object. A classroom is an object. Okay. Now, what do we get at the end of this way of thinking? We get an object model. And an object model in object-oriented analysis represents the information system in terms of objects and object-oriented concepts. So think of it like a map, like Google Map. But instead of the streets and buildings, it's showing all the important objects and how they relate with each other. But then the question is, why should we even consider this approach when it comes to system analysis? Why should we consider object-oriented analysis when it comes to systems and analysis? Well, it makes it easy for us to understand a system. I mentioned an example with regards to GCT that we can say a student is an object, right? So if we are saying that a student is an object, then this student who is an object is being represented in a real world representation. Okay, so we can understand that when we pick a system and we find students within that system, we can connect certain other things to that system. We can connect courses to that system, probably lecturers. We can connect faculty to that system. So it gives us a real world representation of things happening around us. And then we also have another key reason for object-oriented analysis, which is modularity and then encapsulation. Did you do introduction to programming?
Yes, please.
Hello?
Yes, madam.
Okay. So you did
Yes, madam.
encapsulation, right? If you did introduction to programming, then you should do encapsulation. Okay, so with modularity and then encapsulation, it's like each subject is a self-contained unit. Okay, and it's bonding its own data and actions. So it makes the system more organized and easier to manage. So looking at the students we use as an example of an object, okay? So if you're thinking of a student object, then that means it has its own information, such as student ID, maybe student course, student grades, and all of those things. So that is what modularity and encapsulation is all about. You can see a student, but then within the student, you can see the courses, the grades, and all of that. Encapsulation covers all of that so that you don't necessarily see all the details at once, but the key thing there as a student. Then reusability. Once we define a student as object, we can use that same blueprint to create many different student instances in our system. Okay, so it's like having a cake molder. If you cook and you have, or a bread, what you put the bread in to put in the oven. If you have something like that, you can use that same thing to produce different types of bread. Okay, you can make a lot of bread from that same container. So in a nutshell, object modeling is about identifying the key things in the system or in a particular system. Then you define their characteristics and behaviors, and then show how these things interact to build the software or the system you're working on. That's basically what it is all about. So let's look at some reasons why we need object-oriented analysis. The first thing is integration with object-oriented programming languages. So since we are preview to programming languages, at least we've done C++. I'm sure moving forward, you'll be looking at Java and then Python. And although HTML is a markup language,
Hello,
there are
madam.
other. Hello,
Yes, good afternoon.
good afternoon.
Please, can you go back to the previous slide? I want to ask a question on the modularity and the encapsulation.
Okay.
I think I'm quite confused with regards to the differences. So are we saying that the modularity has to do with the separate components, but the encapsulation deals with the data that is found within the components?
Okay. So what do you think? Let me know your view about it first.
No, so
What do
I
you
am
think?
just okay. So for me, like the modularity has to do with models or components. Separate
Okay.
separate components. So taking a
Separate
user, yeah,
components.
separate
Okay.
component. So taking a system with a login system. So we can have a
Yes.
model which is specifically for that login. Then we can
Mm-hmm.
also have another model responsible for checking the validations and other stuffs.
Okay.
Okay, so I just want to know the connection between the modularity and the encapsulation, since you made mention that the encapsulation bind the data, kind of, if I recall it
But
correctly.
all right. So what you just explained to us has to do with the modularity. But then what is your thoughts on the encapsulation?
So for encapsulation, I don't really understand it. That's why I want to.
That's why, oh, okay. So like you rightly said, modularity are different components that come together, right, to build whatever system. So they are independent parts of a system. So like I rightly stated, if you are using students as an example for an object, definitely there are different parts of that student that functions independently, like the courses. The courses is way different from your grades, although there's some sort of connection. But courses operates separately. At the end of the day, when you are being given your final grades, it operates separately. The lecturers involved within the student's figure are also separate entities, but they all come together to work within what that student field. So that is definitely what modularity is all about. But then encapsulation, on the other hand, has to do with the hidden or internal details of a model. Okay, so we are looking at maybe the students again as an example, but then there are things that are hidden. If I see you as a student right now, I can't tell your grades, can I? But then you remember that when we're talking about modularity, we again mentioned that grades are separate entities, courses are separate entities. And when it comes to encapsulation, because I see students as an object and not the grades behind the students, it is kind of hidden. Please, do you get the idea?
Yes, please.
Have I explained enough or it's still not very clear?
This is okay.
Okay, so how do I even put it? Modularity is about dividing the system into parts. So we have different parts. But then we'll say that encapsulation is about protecting what's inside these parts, such that we can't just see it and then we can identify that, okay, behind the students, this is what we have. Please, do you get the idea?
Okay, so can we also say that the encapsulation kind of encrypts the data within the
Perfect.
models?
If it's within security, cyber security or
Yes.
security, yes, in a nutshell.
Okay, so it means that
That
the
was
data within the model cannot be called outside the model. It's the work of the
sorry.
encapsulation to protect it. Yes,
Of
I'm
course,
asking that. Okay,
of course.
so
If
the
that's it.
encapsulation is just a security guy behind the front door.
Okay, so we are not looking at data analysis per se.
Okay,
In this situation, we are looking at a system. So we are trying to say that when you present a system to us right now,
okay,
like GCTU. The moment you see GCTU, you can actually tell the modulations, different parts operating on its own, right? But then
okay,
encapsulation also tells you that the moment you see GCTU, you don't get access to students' grades or results just like that. So certain things are hidden, although they are still parts of the system.
okay.
Is it
Very well.
clear?
Yes, please. It's well. It's
All
well.
right. Okay. I hope I was able to explain to your understanding. Anyways, please, any other question before we continue?
Madam,
Yes, sir.
hello.
Yes.
This a suggestion
Okay.
or an input. Okay, so I would also like to explain encapsulation from the programming point of view.
Okay.
So we can say encapsulation is about hiding the internal workings of a system.
Okay.
So in a model, we can hide the internal workings of that model. Then we can
Mm-hmm.
expose what we want to expose through,
Expose.
let's say, through an API.
Okay.
Yeah.
Okay. Thank you very much for your contribution.
So there maybe how that particular model handle data or how the algorithm is used. We decide to hide it under
Mm-hmm.
encapsulation.
Okay.
With
That's
then
good.
we can expose through the API.
Okay. Thank you
All right.
very much, Roger. And please, I didn't get the name of the first person who asked the question. Who was
Justice,
that?
I am.
Oh, okay. Justice. Thank you. All right. So please, basically, that's what we've explained. Except we have any other questions, can we move on?
Sure, please, you
Okay.
can move on.
All right. So we are talking about some key reasons for object-oriented analysis. And we are looking at integration with object-oriented programming languages. So I was saying that you have done C++, I think. Please, have you done C++?
Yes, please.
Okay. So definitely you'll be doing Java, Python, and I was saying that although HTML is a markup language, if you do intensive HTML, that means you will be adding some styling sheets to it. And definitely you'll be coding in JavaScript as well. So all these are object-oriented programming languages, okay? And so when we talk about integration with object-oriented programming languages, we are saying that if these models are created during analysis, they can be directly translated into code. It's like having a blueprint that speaks the same language as all the builders, okay? So rather than just coming together from somewhere using the idea of the codes you have for C++, because in case you want to write a code to maybe add two numbers in C++, I'm sure you have an idea. But what to bring this idea to life? You need an integrated development environment, right? Which is like an IDE. And what IDEs do you use for your C++? Probably code blocks. Some use Visual Studio and the rest. So the integration with object-oriented programming languages helps you, the programmer, to have access to these IDEs that can just help you put whatever codes you want to put together and then bring them to Fusion. Please, I'm sorry for my background there. There's something going on outside my home, but then I think I can hear the sound still, no matter how I close it. The encapsulation here is not working very well. That's just by the way. So please forgive the background noise. So imagine coding today without all these IDEs. You want to code something in C++, but there's no code blocks. How will you go about it? Do you get the whole idea? So object-oriented analysis helps us integrate this object-oriented programming languages so that it will be easy for us to what? To code with. Then we have scalability. Systems grow day in, day out. I'm sure when Facebook started, they didn't know that they were going to have over 1 billion people on it, right? So Object-oriented design helps us manage that complexity in terms of volume. If it is well organized, you can keep building without the whole thing was collapsing. And that is another reason why we need object-oriented analysis. Another reason is the enhanced communication. So in this case, it helps us ensure that everyone is on the same page, okay? Everyone understands how the system will work, and everybody has a visual kind of representation of how the project will go. That's what it has to do with enhanced communication. For support for design patterns, there are pre-built solutions to common software design programs. So we have a lot of frameworks these days that, for instance, you want to build a website, you don't have to start coding from scratch. All these things are available for us to work around with. And this object-oriented analysis supports these design patterns, okay? So think of it like maybe using a common recipe, probably which chef do I know who is trending now? Chef Abby. Chef Abby has brought a nice recipe for cooking fried yam. Okay. Instead of starting from scratch, all you can do is just to take that recipe and then you are done. You want to build the website, all you have to do is to just get that script, that framework, and then do your editings and all of that, and you are good to go. Another thing is the flexibility and then maintenance. If we need to change how a particular object works, what we can do is we can take parts of it and work on it. We don't have to bring the whole system down before working on it. So that's another reason why we need object-oriented analysis. Then efficient, I think enhanced security, of course. With security, object-oriented analysis uses encapsulation to hide the internal details. Okay, so it keeps all the sensitive information locked away. Okay, you don't have to really know how the whole thing works for you to run a particular code. Yours is to just enter your codes and then enter run, and it runs it for you. How it goes about it, you have no idea, but it keeps that for you. And efficient problem solving. Of course, it will help us think about the problem in a more structured way. It's like tackling a puzzle. So you go to the first part, what am I supposed to do? What will fit here? What will fit here? And then it goes like that. Sechwafia, your hand is up.
Thank you, madam, for the opportunity.
Yeah.
I hope you had a nice time celebrating your Easter.
Oh, I don't think I celebrated it too. Nobody brought me chicken or cow or anything, so
Don't worry. Try and come to face next time. We'll bring you that one.
I see. Anyways.
Don't worry, I'll
I
get
just
you some.
wanted I just wanted to clear out something. The subheading is that some key reasons for object-oriented analysis popularity.
Yes.
And during your explanation, you said the reason why we need object-oriented analysis, or are these the reasons why it is
They
popular
are
in our
popular.
system development, or this is the reason why we need them? I just want that clarity.
So I actually said you need them because if something is popular, definitely you should be using it. Is that not it?
I also know that majority are not always right. So I
Well,
just wanted to.
in this case,
Yeah.
let me just ask the simple question. You want to build a website and you see a framework. Would you rather start from scratch or use the framework?
It depends. It depends.
Madam, please, I'll use the framework. I'll copy
Definitely, because
everything, edit
you
it
copy.
to my choice. Stop lying. I can't stress myself. But if you're going to code from the beginning to the end, it's not easy to take you like weeks. I like soft life.
Please, if I teach HTML, Introduction to Web Development and Web Design. If I give you an assignment and you bring me a framework, I'll mark you wrong.
Oh, madam,
Why?
you're
And
Why?
then you
Because
see
this one is not
sometimes
a working
when
environment.
you
oh, madam, you're
when you code it
encouraging us.
yourself, when you
Oh,
start from the scratch, it give you more understanding of what you're actually
Very
doing.
good. And that is why we teach you the the scratch, the basics, so that at least when you go out there, you know that, okay, there are frameworks, there are this thing, this are that. So, you use the beginner's knowledge and then you implement that in what you are working with.
But the framework also give you the understanding. No? Like if you know your left and right in the scratch building, when you're
Mhm.
editing the templates, you know what to build.
It becomes easy. But me, don't bring me the framework. Why do you think I gave you the assignment?
Yeah, madam, but
There are
this one you're
challenges
teaching
in the
us.
framework. Oh. When you do
Sorry.
something yourself, you can easily amend it yourself. If
No,
there's
it's
any
not. It's
problem,
not
you
like.
can easily
Oh, but the
identify it
template
and then
you
make
can
changes to it
amend it
than
yourself. Oh.
following the
Please,
framework.
one at a time, please.
Just says, please, the template you can amend it by yourself and then do it as your own. Then you own it. Then the documentation you set it to own it.
Mm-hmm.
Yes,
Mm-hmm.
you can do it
Soft
that
life,
way.
soft life, madam. Soft life, madam. Soft
Oh,
life.
Giving us soft life.
this one is not soft life, madam, but I'm being honest with us. Because, madam, see, some of the templates, you have to really understand what you are doing. Then, when you get the understanding, the little knowledge you have about, let's say, HTML, maybe you're
Mm-hmm.
building a website for maybe a beauty a salon. When you
Yeah.
download it, you already have knowledge about what you are doing, and you already have some basics from it, or maybe the ones maybe from scratch, the one you've taught us and all of that. So if I take the templates, definitely I know what I'm doing. I may not build it from scratch, but I know what I'm doing.
Yeah.
Editing the barcode to suit me. I'll edit it to suit what I want. And then
You
my
want.
front page, I'll change the colors to my perfection. How I would want I start everything, the graphics to catch my audience to
Audience
come and
attention.
shop. You see, so madam, please give us some credit to see. Thank
Okay.
you, madam.
Oh, Angelina, you are not
You're
wrong.
welcome.
But the thing is, when you are doing it yourself from the scratch, it gives you more insight on what you're actually doing. It's not like you don't know anything. When you are using the framework, you don't know anything about what you're actually doing. But when you are building it from the scratch yourself, you really get the insight. You understand what you're actually doing. I don't know if you get my point.
Yes, I get your point. But right now, there are lots of people who they've not gone for they don't have any IT background, but the little they learn online, they are good to go because of the templates they are using. So right now, if we knew that as time goes on, as the IT changes and all of that, we will be getting templates and how to build platforms that easy. Like, I'm not sure lots of people would go and learn software engineering and code from scratch till now. Right now, the
Let,
new
It is a
let's
platform
relax.
competition
That's
developers.
why.
base, a competition base.
Do
No,
you
right
know
now
I will
that?
also say that.
the new
I will
type
also
of
say that.
right now the new set of
Uh,
developers they don't code from scratch. Oh, the new set of developers we have in town,
yes,
the
yes,
language
because they are already in the field. They're already in the field. Let's say
no, they are
we
not
are
in the
not in the
field.
field.
Though.
No,
Now,
no,
you are
because it
coming.
is a
I'm coming.
competition base.
This is based on, let's say, academic purpose. From academic purpose, we need to start from the scratch. But let's say you are already in the field, and let's say you are building a website or something for someone. That is cool for you to use the frame. Do you
Frameworks
get it? But since you are
for
in the academic,
academic purpose.
yes,
There's
you are in
there's this
academic.
saying,
You have to
don't be caught.
do with it.
Don't be caught in
And don't worry, you will
in
never
the
catch us.
academic
Don't worry.
setting.
Yes, for
Don't be
academic
caught.
purposes, we'll do it for you to give us a marks. That one day we'll do it for you.
You do
But
it. You
when
go
we
and
get the
copy and
job,
bring it.
oh no, madam, we code from scratch. We are good students. Oh, what else, please? You do from scratch.
So I've been marking HTML projects for maybe 3 years now. And students, you see, for me, when you're presenting your project to me, I need honesty. If you didn't do it yourself by yourself, like just tell me, oh, I use this framework. Oh, I used Bootstrap. Oh, I used WordPress. I use this. Just tell me. Feel free and then let me know. And there's something I also expect. The fact that you used it does not mean you just copied and pasted. There are people who can actually defend what they've done. They are able to tell you, although I used Bootstrap, I used this and this APIs, I did this and this and this here. Initially, it was like this, and I applied this and this tax. So the person knows what he's about. or he or she is about. But in a situation where you come, you don't even know, there are people who go to others to help them do it. They don't even know what the person used. And then they just come and then show you the
Because I'm
project
at
and they are like,
lectures now. I'll call you because our lecturer was out, but he's in now.
sorry,
So I'll see you in the evening. Okay. I love
please,
you
who
very much.
is,
Bye bye.
hey, hello. Please mute your microphones here, because when you interrupt like that, you kind of confuse the thought process. Okay, so that's just by the way. So these are key reasons for object-oriented analysis popularity. We are able to do what? Use it when it comes to integration with object-oriented programming languages. In terms of scalability, it enhances communication, support for design patterns, flexibility and maintenance, enhanced security, and of course, efficient problem solving.
Hello, madam.
All right. Yes, sir.
Please, I have a question.
Okay.
Yeah, so going back to the OO analysis and the structured analysis, are we saying that the structured analysis does not support for design patterns?
It doesn't what?
It doesn't support for design patterns.
It doesn't support for. I
Yes,
don't
you
get
are
your
saying that the
question.
OO analysis supports for design patterns as part of the reasons why we are choosing that. And I'm asking that with regards to the structured analysis, does that also
Oh,
not?
okay.
Yes, so that's my question.
Oh, okay. But what do you think about it? No, when you ask me the question, I have to know what your thoughts are so that I can know where to come from. Or
Okay,
you've not
so
realized when you ask the question, I ask you.
yes, definitely, I have realized that. But
Mhm.
the whole
Yeah.
point is that one of the reasons why we are considering this as the best option for design pattern is the support for design patterns. But for structure and analysis, I think that one too, you can also apply the design patterns regardless. Or
Yes, kind of. When we spoke about structured analysis, did we mention anything about it supporting design patterns? I don't
no,
think we
please.
mentioned anything about that because with structured analysis, it uses the traditional approach. It uses the
Which is the
data flow
procedural
diagrams. Yes,
procedural style.
stuff, yes. So it does not really use it does not really support the design patterns. If not, we wouldn't be talking about object-oriented analysis.
Oh, okay.
I don't know if you get the whole idea.
Sure.
So,
I
madam,
get it.
Yeah.
just a quick one. So it means with the structured, it doesn't support it, but the OO analysis it does.
Yes, the same way with the structured, it doesn't support objects or classes. It also doesn't support encapsulation. So we didn't mention anything about encapsulation in that. And when you said you did C++, so definitely you did inheritance and polymorphism.
Yes, please.
So structured analysis does not support that either. Okay. And it normally doesn't focus on the procedures and the integrations, the IDEs like this. We didn't speak about IDEs when we're talking about the structured analysis. I don't think we did. Please, any other question? The way the questions are coming there, people really enjoy the Easter. That's nice. Anyways, let's proceed. So this is a figure that represents or depicts the parent object, which has attributes and methods. Okay, so I'm sure you can see the diagram very well, right? We can see parent as an object. Okay, so if we are seeing parent as an object, think of it as a general blueprint or a class within this parents. And within this parents class, we have two main things. We have the attributes and the methods. Okay, so the attributes there are name, age, sex, hair color, and then the methods are read bedtime story, drive in the carpool. Is that carpool? Yes. So the objects contains attributes and methods. So in the same way, if we are talking about car and we say a car is an object, what will be the attributes and what will be the methods?
Hello, madam.
Yes.
So attributes, I think it can be the color, the make, and also yes, the color and the make, and also
Okay.
the brand as well. But with the method, the car being able to accelerate, that's the method, the behavior that the car is exhibiting.
Oh, okay. That's cool. Do we have any other?
I'll also say the attributes can be the model, the color, and the methods can be, let's say, drive forward, reverse. Yeah.
Awesome. 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 So in this case, we are saying that parent is an object. And within the parents as an object, the parent has attributes. That means the parent has a name, the parent has an age, the sex of the parents, the hair color of the parents, and then what the parent does. That's the methods, right? Okay. Then we also have what we call instances of the parents. Instances of the parents. That means the parents can have other instances, and these instances would take the form of the real parents. So, like I mentioned earlier, the parent as an object is like a blueprint, okay? And then it can have other instances. So, the first instance of the parent object here is Mary Smith. And Mary Smith must also have attributes, just like the main blueprints, the main parent objects. Do you get it? And it must have methods. It also have another instance like Ahmed Ali and another instance like Anthony Green. Okay, so Mary Smith is one instance. She has specific values. She has specific attributes. And these attributes are defined in the parents class. The same applies to Ahmed Ali. He has a specific attributes. That is what defined in the parents class. And then Anthony also has what? The same thing. Please, do we get it? So this is the idea of what object represents. So back to the first example I used, students. So if student is an object, what will be the attributes of the student and what will be the methods?
Madam, I think it will be the student sex, whether male or female, the
Yeah.
student ability.
The name as
Ability in
well.
terms of what?
Please come again.
Ability, like, I want to understand ability.
I don't think ability should be part. Maybe the student sex, the
I think the
student,
type,
the,
being a
the
male or female.
yeah, that's the sex I spoke about.
So student name, the sex, the age, and probably
Madam,
the
can
course.
the course the student is offering be an attribute?
Definitely. The
Yes,
program or
yes,
the
it's an
course.
attribute.
So we can have students' email, students' GPA, their level or year, all these can be attributes. Then when it comes to the methods, what are we looking
Hello,
at?
madam.
Yes.
So if we are looking at the attributes, basically they are the characteristics or the features of that
Of
object.
course.
Okay.
Of course.
Attribute
okay.
means characteristics. So
Yes, yes, Mr. Broffelman. Thank you. Yes, so how about the methods?
So one of the methods can be maybe to join class, to write
Good.
exams, to learn.
So good, good. So we are
To
looking at what
cheat,
the students does, the
to cheat.
actions the students perform. So if we are looking at students as an object, what will be the instances of that student?
So the various students, let's say Justice, Rafik, yes, those are the instances.
Awesome, awesome, awesome. Do we have any questions? Any questions? All right. Then let's proceed. Then we also have this figure here, the child object, which also has 5 attributes and 5 methods. So basically, it's what we've explained with the student and the car and all of that. All right. So these slides explain what attributes are. Like we said, they are the characteristics that describe what's the objects. And then in an object-oriented system, objects can inherit specific attributes from other objects. Okay, and these attributes are usually represented as variables within the class definition in object-oriented programming language. So when a programmer is creating the blueprints, say students as an object, they will definitely define variables to store the student's name, right? They will define variables to store the student's ID or the student's grade and all of that. I don't know if I can write a C++ program here. Okay, so imagine we want to write a program in C++, and then we are creating an object student, and we want to assign certain characteristics to the object students. And these will define what the variables that are being stored within the object student, such as the ID, the student's name, student's grade, and all of that. I'm sure we can do that in C++, right? I wish I could write it here, but I can't code with this thing here right now. But basically, that's the idea. So we are able to store all these characteristics within the objects, and it helps us understand the kind of variability it all has within that particular, programming language. Just like I mentioned, if you are creating an object for a student or a student as an object in C++ programming, there are certain values of variables you assign to it, and it stores that variables such that when you run the codes and you enter maybe student's name is equal to SNM, student's ID is equal to 4211234. The moment you search for student's name, Deborah should come. When you search for student ID, 42 what not should come, right? All right. Objects can also have a specific attribute called a state. Okay. The state of an object is an adjective that describes the object's current status. So if you have a light bulb and this light bulb is an object, it can have attributes like the color, the type, maybe the wattage, and all of that. But then its states can either be what? On or off. Okay, so the state is just a dynamic attribute that can change over time as the object continues to interact with the system. Another example could be a door. So if a door is an object, it could have attributes like maybe the color, it could be Odum door or Wawa door or which other door? China door or Japan door. Okay. But then it could have a state like it's either opened or closed. So while attributes are general characteristics, the state is a specific attribute that reflects what? The object's condition at a particular or specific time. Okay.
No, madam.
Then we have, please, any question?
Hello.
Yes.
So taking a student, when we say a student, it's an number. When we use the sex as the state, and the sex as in male or female as the state.
Please, I
Because
can't
the
hear
sex
you
applies
clearly.
specific. Can you hear me, please?
Yes, I can hear you now.
So when we take a student, when we use
Yes.
the sex to describe the state, because it talks about whether the person is a male or specifically distinguishing which kind of sex the person belongs to, the student belongs to.
I still don't really get where you are coming from. You said when we take a student as an object, and
Yes,
then the
I'm citing an
attributes
example.
of the student, yes, and the
No, the
attributes
state,
are
the
what?
state, the state, the state.
Okay. So the state of the student is what? The sex.
Maybe you could exactly.
Then what will
Which
be
was
the
if maybe
attributes?
it may be a male or a female. If the person is a male or a female, specifically distinguishing what kind of sex the student belongs to.
Not, not really. If I get you clearly, then that's not what state would be. So let's take the student again and let's talk about the attributes of the students. Okay. So we are saying that the attributes of the students is what? Name, ID, the sex, and then what? And what have you? The state will neither be the name or the ID or the sex. The state will be the current state that student is in. Is the student tired? Is the student happy? Is the student sad? Is the student studying? Like, please, do you get the idea?
Yes.
So it wouldn't necessarily be the attributes itself, but a specific attribute within that attribute, kind of. Emmanuel,
So you can
your
use
hand is
pass
up.
or fail.
Yes, kind of. Emmanuel,
Yes, madam.
yes, your hand is up.
Yes, please. I wanted to ask if maybe you can practically demonstrate, uh, uh, for example, about the assignment you give to us concerning
Yes.
putting that in the equation. I want to. Is it possible that you can
Putting what in the
demonstrate it?
equation?
I mean, inserting objects like the drawing and the practical aspect. I don't know if you can demonstrate it practically for us to maybe because what I want to talk about is mostly you do theory aspect, but in a practical aspect, I don't I want you to help us so that we also can learn from it.
Okay, so I still don't really get your question. Can you come
So,
again,
madam,
please? Yes.
yes, so he's trying to say that the
Mhm.
assignment that you gave us, mostly you asked us to draw a data flow diagram, that last
Mhm.
assignment you gave us. He wants
Mhm.
you to demonstrate to us how we can put all these things together in a practical form. That's what he's trying to.
Oh, okay. But I'm trying to connect the question to the attributes and the objects you are talking about right now. Or it's a different question altogether.
Yeah, I think so.
And please, the one who asked the question, can you come and then clarify? Emmanuel, I thought you were the one asking the question, or he was not the one.
Yes, madam.
Yes.
Please, yeah, if I can come clearly, I just want you to also add a practical aspect to what you are teaching so that we also can learn from that side. So that in case of assignment, we can also apply the same thing to,
Um,
I don't know if you
honestly,
can get.
I'm not really getting you. So, for instance, let's deviate a bit. The data types, I mean, the data flow diagram, were there not examples within the slides we used when I was going through it with you?
Hello, madam.
Yes.
I think the whole issue is that, like, maybe we take a case study, an example question to solve how we can connect this diagram together. Maybe that's what he is trying to. Example,
Uh,
like what you are teaching right now, maybe you can get a case study to relate to us how we can solve some questions in that regard.
oh, but is the purpose for solving questions, honestly?
Like being able to connect what we are learning into real world.
Okay, I get you, but I'm still finding it difficult. So let's come back to this slide. We are talking about attributes and states. Have we not used real life scenarios, as in students as an example, cars as an example, or there are still other things you're supposed to use as an example? Like, I want to really understand your thought process.
Adam, but please, I would like to, I feel like the whole concept of object-oriented analysis system, I
Mm-hmm.
think we would like you to probably come with it in a more practical way to help us relate it to real world. I think that's where the whole problem is coming from, because attribute, we all understand what attributes is, and then
Do you?
we
Because
understand
somebody
what.
had to actually explain to somebody else that it means the characteristics, and we are still answering questions about this. So, if you want a real, so what mostly the lecture is all about is we tell you what it entails, the components that comes with it, and then we give you the assignment so that you use the context and the components and all the pieces, you piece them together to do your assignments. I don't know if you get what I'm trying to say. So if I don't teach you what a status or attribute is, how do I give you a case study? Please, do you get the idea? If the lectures are all about having case studies and solving case studies, then we shouldn't even be going through this entire slide.
Okay,
Please, do you
madam.
get me?
Yeah, sorry, you see
Okay.
the other slide that we spoke about the attributes and the method. Please go back
Yes.
there. So if we are citing example, in a
Mm-hmm.
case, no, the other one, in a case where we are building maybe student, something for students, like we cited example, with the primary ID, and then
Mm-hmm.
the student, the attributes, so the student name, age, and everything. Then we state the methods, which I don't know how to put it, like which tells us telling us the attributes of the characteristics of every student. Is it still in the same relation to what we are teaching about the attributes? Like you see, we mostly do it on that Excel sheet, which we create the primary ID, and every student also has their ID.
Of course. Did you do database or
A
anything?
little,
Sorry?
a little.
Okay. So it's basically like that. And it cuts across. There are so many things you did in information systems that are reflecting here. There are things you do here that will reflect in programming. There are things you do in programming that will reflect in what else? The other courses you do. But if we should just be taking, okay, well, I think I get you to an extent. But the fact that we go through all these things does not mean when you are giving a case study, you shouldn't be able to. The case study is not outside the scope of what you are being taught. It is for you to put the piece and pieces together and then analyze what you've been given. But don't
Madam,
worry, moving forward, we'll try and then bring in more case studies.
please, can we do something like that? Like the example I just said, so that it will make some of my colleagues be on the same page, everybody. I don't know if you get it. Because
I
I
get
think,
you. So you want a case study to understand what attributes and methods are.
okay.
Okay.
At
Is
this
that
point, I think we are all not on the same page. That's why we are requesting for more case studies to understand it. But I think if we do that, and so it should answer all our confusions and everything, so that we all be on the same page with you.
okay? I get you. Please, do we have any other questions? All right. So let's say GCTU is developing a system to manage student records. And then what else can we add? Student records, course registration, and then results. So, and your task as this particular class is to develop or design a student class, okay, in OO programming or object-oriented programming to represent all students in the system. What will the student class now define? What will be the attributes of the student class? Please, do you get the question? We are designing a student management system for GCTU, or we are developing a system to manage their records, and we want to manage their students' records. We want to manage their course registration, and we want to manage their results. So what will the blueprints be? Anybody? Emmanuel, yes.
Now, very well. That's the exact question I'm trying to ask about concerning in a practical way. Can you help us to understand it more than asking us to solve it? So maybe so that you can help us understand it in a practical way. In case, for example, looking at the diagram here, I don't know. I just asking. Well, I don't know. Is it AI they use or you do it yourself so that you also can learn it from you?
So
That's what I meant by that.
I just asked a question, Emmanuel. Did you hear the question?
Maybe I was having a stable network, so I didn't hear.
Did anybody hear the question, please?
Yes, please. We heard the
Okay,
question.
so you
Yes, please,
requested
we heard
for
it.
a real case study or a real life example, right?
Yes.
Please, is it like we don't understand the way I'm communicating the whole thing to us, or
Oh, we
I
do,
want
we
to know
do,
so
we
that I
do.
can also
We,
improve
we are
myself?
We
following.
do, we do,
We
we
are
do.
following.
All
Please,
right.
we do.
So I'm asking now, you want a real life or a case study. And I'm saying, let's say we are building a student or developing a system for GCT, okay? And this system is supposed to what? Manage student records. We want to learn how to manage, or we want to build a system that will manage what students' records. So we are representing that by R, or students' course registration, and then their results, right? Okay. So these are the things we are trying to work on. And we want to start with a blueprint. Mind you, what we are working on has to do with what? The students. So what will be the blueprint? That was the question I asked. So using
Madam,
object-oriented programming, object-oriented analysis, what will be the main blueprint we are working on?
I think you should
Somebody.
first
okay,
have
Madam, hello, Madam.
Yes, Richard.
I think from the GCTU will be the parent, then the course registration, the results will be the attribute.
Okay. Okay.
Hello,
Any
madam.
other submission? Yeah, Rogers. Is it
Okay,
Roger?
so this is Justice.
Justice, okay.
Yeah,
You
so
should
I want to.
a primary.
Please, can we do it one after the other? Thank you. Yes, Justice, I'm
If
listening.
you have a
All right.
primary,
Yes,
Hello, madam.
Justice. Yes.
Yeah, so like I'm saying, the main class will be the name of the project, and also the objects are the sub components that are found within
Okay.
like the
So
results,
what
the
are we
course
working
management,
on? What
the
exactly are we
student
working on?
management system.
Good. So what will be our blueprint, our objects,
So that
main
will be the
objective?
student management system.
The students.
Yes.
So you identify the students as your object before you are able to tell the attributes and the methods. So in this case, the student attribute will be what? The student ID, student name, student program, level, and whatnot. And I think we've gone through this as examples over and over and over again. Is that not it? So I'm trying to reconcile how the explanations I've given so far works with your case study. Or is it because I didn't say, let's say we are building a project, or let's say we are building a system? Please, do you get where I'm coming from?
Very
Yes,
well, madam.
madam.
So please don't get confused. In the case where I used, okay, let's say we are building students' records, we are building a system for GCTU, and the system has to be able to, manage students' records, students' courses, student registration, student results. Like probably it's a lot, but it's connected to just one person. Who are we looking at? Who is the main blueprint we are looking at? Who is the main object in this? So probably because I didn't use that, it's kind of confusing, and it's kind of does not sound like a real case study. Is that it? Then that shouldn't be a problem at all. It's not a problem at all, at all, at all. Can we continue, please?
Yes,
So
please.
now that you've brought it, I'm sure I'll be bringing in more case studies. Let's say this is it. Imagine we are doing this and this and that. Is that okay?
Yes, madam.
Thank you. Thank you.
All right. So let's move on to methods. So an object has methods, which are tasks or functions that the object performs when it receives a message or command to do so. So imagine you have a remote control. In this case, the remote is the what? The message sender, right? Because when you hold a remote, you can press it and then it will change something or stay somewhere else or move to another part of the screen or whatever, right? And then you have something that you use the remote to control. So in this case, if I'm using the remote on a TV, the TV becomes what? The object. When I press the volume up button, I'm sending a message to the object, right? Or I'm sending a message to the TV to what? To perform an action. And what action am I telling the TV to do? To increase the volume, right? That becomes the methods. Please, do we understand?
Yes, madam.
Yes, madam.
Okay.
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 So in this case, what case study can we use to explain better?
Think
Yes.
a car.
Okay. So,
The car itself is the object. When you move it, it does the action that it is performing, which is the method.
okay. Nice. Do we have any other?
Madam, can I say that, excuse me to ask, can I say that a hotel has an attribute of rooms that have to be booked for people, and then the booking method, the booking way is the method?
Awesome. That's smart. Yes. That's cool. All right. At least we have the idea, or we get the idea now. So methods perform what we call operations, like the way the person will now book the hotel and all of that, right? Methods perform operations, manipulate object attributes, and implement the object's behavior within what? A system. Okay. They define how the object can interact with what? Other objects. So it can perform a specific task. For instance, we want to book the hotel. How do we go about it? That's the method being manipulated. Probably we have to go to the front desk and pay for this and do that and all of that. Okay. And then it manipulates what? Object attributes. So methods can change the data an object holds. So for example, the attribute is like the money in your bank accounts, and then the ATM is like a method, or the method is the ATM. You don't have to go inside the bank vault to change the money there after using the ATM, right? So once you use the ATM, which is the method to deposit or withdraw, you get whatever you still want. Please, do you get the idea? All right. Some characteristics of objects methods include the following. So we have interaction and collaboration. We have encapsulation and security, flexibility and maintainability, clarity and understanding, enhanced modularity, and reusability. So let's take it one by one. When we talk about interaction and collaboration, what do you think we are talking about? What does it mean to you?
Hello, madam.
Yes.
For me, I think since they share the same or similar attributes from the same parents, they are able to interact with each other easily.
That's good. That's great. Now let's take a case study. So let's view let's analyze a particular object. Okay, like a student in the university system. Okay, and then we know that the methods are the actions the students perform, right? Maybe registering courses, checking results, and all of that. Okay, so let's relate that to interaction and collaboration, the characteristics. In this case, what will it entail? Please, do you understand?
Please, can you come again with the question because I think I didn't hear.
Okay. So we are looking at some characteristics of object methods, right? And I'm saying that let's take a student in a university system as an object. What are the methods the students can, perform, or the actions the students can perform? The students can register his or her courses.
They can all write exams.
They can write exams. They can check their
Yes, they can
results.
check.
They can update their details and all of
Attend
that.
lectures.
Attend lectures. Good. So now let's introduce this into the characteristics we are discussing. In terms of interaction and collaboration, how does this affect the object? Or what can the objects do?
I think, hello, madam.
Yes.
I think the object is able to interact with the system in such a way that he is able to access, register a course, view a result, and do other stuff on the system.
Awesome. That's great. Any other? So that's where the interaction and collaboration, that's what it entails. The student is able to get access, interact with the system, Because for you to register your course, you have to interact with the system. Is that not it? For you to check your results, you have to interact with the the school's database or the system's database, which will now retrieve the results that's stored in it to you. Okay.
Madam, please, can I say that the
Mm-hmm.
interaction and the collaboration comes, it can be that this is where the object interact and collaborate with the attributes, if I may.
The attributes.
Yes.
We can say that, but that would, in this case, it would depend on the attributes. Are we talking about interacting with the attribute sex or the attribute student ID or the attributes? Please, do you get the whole idea?
Yeah.
So it may not necessarily be that, because if I'm talking about an attribute like my student ID, how am I collaborating with my student ID? Or how am I interacting with my student ID? Do you get it? But in this case, methods are what allow you to do what you want to do. Methods allows the object to what? Communicate and work together. So if I'm a student, then I should be able to check my results. So students as an object will interact with what? The course and the scores of that particular course for me to retrieve my what? My results. Please, do you get it?
Yes, madam.
Okay, so
Yes, madam. Yes, madam.
hello.
Yes. Yes.
So it means with methods, they will have the object to interact with other methods. Sorry,
Yes.
other objects.
Yes. Or the actions that's
So
the
a
object
student,
can.
a student. Okay,
I'm
so when a
listening, please.
student check a result, it's the student is interacting with the result object. Let's say there is an object which is another object which is result, or could be like exam result, which is an object. So the student, through the method, to interact with that object. Is that it?
I'm a bit confused. Now, what is the student? Is the student an object or an attribute or what? What exactly is the student?
It's an object.
Okay.
We've
And it's
learned that the student is an
interacting with,
object.
good. And it's interacting with what?
So the student is having properties.
Hello.
And it's also having methods which interact with other objects, interacting with the
You went,
properties inside, or are they interacting with other objects?
your network was not very stable, so we lost you at a point.
Oh, sorry. Hello.
Yes, so please come
So
again.
I'm saying that we've learned that the student is an object,
Yes.
and it has properties and actions or methods. So properties would be like the ID, the name, the result, or let's say GPA could be a property. So,
Okay.
and then it has actions. So through the actions, is it interacting with the properties, or is it interacting with other other objects?
Oh, okay. So you are asking a question. You are not answering what we are saying.
At first, I was suggesting, like I was giving a point that maybe probably they are interacting with other objects, but
Oh,
you are
okay.
not clear with that. So I'm
Yes,
just
yes,
asking
yes.
whether.
Asking. Oh, okay. Oh, okay. So yes, it also interacts with other objects. So the student as an object can interact with a course as an object. Do you get it?
Okay. Okay.
Uh-huh. Okay. So let's look at encapsulation and security. Still with the students as an example. In terms of encapsulation and security, what do you think?
I think this is where probably the students' results are kept out of the public and are secured. I think probably.
In
Because
this case, sometimes you have to be sure of what you're saying. So not
yeah, so
probably. It's actually that.
because we spoke about encapsulation and also security.
Yes.
So
Yes.
encapsulation is the secrets behind what is shown to the public, if I get it right. And
Yeah,
then the
something like
security part of it is encryption, if I also get that one also right.
that.
So combining the two of them, I think providing the student, for example, we are talking about the student. So their results, keeping their results and making sure their result data is secured
It's
and
safe
safe.
and secured. Yes, that's just it. Such that nobody can just have access to it and then change it or update it directly. That's it. All right.
Okay.
Now let's look at flexibility and maintainability.
Hello.
Yes.
Please, I would like to speak a little about the encapsulation.
At this point, I'll let us skip, unless it's a question.
Okay.
Yes. Or you can keep it. When we are done and we ask other questions, then you can bring it up so that we'll be able to cover all the things we want to do. Flexibility and maintainability, yes. So let's say you wrote system analysis exams this semester. I checked your results and you see X. Do you think we would have to bring the whole grade system down to be able to fix your results for you?
No, please.
No, please.
Good. So it's actually flexible, although there are security measures such that nobody can just go there and then change it and all of that. There are still ways to, you know, rectify those situations without breaking everything apart and then starting from scratch again. For instance, when your GPA changes, currently you guys are using 40-60, right? 40 for coursework, 60 for exams. So in the event the system automatically updates to 70-30, do you think we'd still have to bring the whole system down and now come and check everybody's results one by one to do that? No, there will be no need. That's why it's flexible and then the maintainability is also great. Okay. So it helps maintain or it makes the system easy to maintain and then adapt over time. Then clarity and understandability. Clarity and understandability. If you take your student's LMS right now, you should be able to understand everything it's saying. You should be able to follow whatever it is on it easily, right? That's another characteristics of
So,
object
madam, can that
methods.
also be termed as user-friendly?
Yes, user-friendly. And then enhance modularity and reusability, excuse me. So methods allow you to reuse functionality in different parts of the system. Okay, so instead of maybe, for example, a method that calculates a student's grade, it can be reused. It can be reused in the student's portal or in the lecture system or in report generation. So instead of rewriting the same logic for students portal differently, lecture system differently, report generation differently, you can just write it once and reuse it to save what time and then effort. So all these are some characteristics of object methods.
So, madam, can you go back to
Yes.
the previous slide?
Okay.
Okay, so the enhanced modularity and there is reusability. Only for under maybe update.
Sorry?
Only for under maybe update.
Updates. Why would you say it's under updates?
Because you said maybe you can rewrite the same code to do other stuff. Because maybe they
So
need to enhance the system so they can enhancement like that.
So if I use, say, an update for login, I mean, not updates. So on on a student's profile, right, like your LMS, a lecturer can put, how do we call it, an assignment there. You can also go there and download the assignment and upload at the same time, right? You can upload your assignment again in case that's where you're supposed to submit it. And I'm writing codes for you to upload the assignments. If a lecturer goes to the same platform and the lecturer wants to upload the assignment, you go and download, work on and re-upload. Is it not the same upload? Do you get it?
Yes.
Yes.
That's where the reusability and modularity comes. It has nothing to do with updates. Do
All
you
right,
get?
madam.
Okay. So this is just an image to depict what we are talking about, methods and then how to go about it. So this is you imagining that this diagram here is a kitchen, okay? And then the kitchen system is the objects. That's the thing that what we are going to work on or perform a method on, okay? And then the method is the task that the object knows how to perform. So in this case, the task the object knows how to perform is more fries. That's the method, right? And then whenever we say more fries, the system must go through some specific steps or instructions to ensure that there's more fries available. Now, let's term this particular diagram here as KFC. When it comes to the interaction, definitely if you go to KFC and you want to buy something, you go to the cashier, right? Then the cashier will take the order and then send it to the kitchen. And then the kitchen will now do it. And the order is more fries, right? So the kitchen will now what? Prepare the fries by following the steps there. Okay, heat oil, fill fry baskets with whatnot, up to add salt. All those processes. Then encapsulation shows us that the kitchen, when the order is given, more fries, the kitchen doesn't show you exactly what they have to do for you to receive your fries. All it does is to follow a particular step or principle, and that thing is controlled within what? The kitchen. The kitchen doesn't just get up and then cook randomly. It follows a standard procedure, which you are not even aware of. That's the encapsulation. So all these methods we spoke about earlier, or the characteristics we spoke about earlier, is just showing us what it entails when it comes to using a kitchen or a restaurant to depict this as an example. But in the previous case, we used what? A student or a school to depict an example for the methods and then how to go about it. Okay, so the method is like a recipe, and the kitchen is the object in this case, performing a particular task. And the method, more fries, is the step by step, procedure or processes it follows to get the job done, basically. Search Wafia.
Yeah, thank you, madam. So in this case, the KFC example you made, so the
Yes.
customer coming in to buy the
The fries. Search Wafia, your network is not stable.
product, is that an instance? So the customer Hello.
Please, who is interfering?
Please,
Setrafia, can you come
can you
again?
hear me? Can you hear me now?
Your network was unstable, so kindly come again.
I was asking that the customer
Mm-hmm.
that was coming in to buy the more fries or the KFC, is that
Mm-hmm.
customer an instance? Because we also spoke about instance.
Yes, that will be an instance.
All right.
But no, in this case, is the customer an instance? No, I don't think the customer will be an instance here. Because the instance must inherit everything the object is inheriting, like the object has technically. And the object here is the kitchen.
So the customer is also an object.
It's also an object.
All right. All right.
Okay.
In a different case, the customer could be an instance.
So please explain to us why the customer will be an instance.
Also, when we are studying the customer as an object, then we can
Mm-hmm.
create an instance for it.
Of the customer. Oh, okay. That's fine. Because we have different customers. That's okay. All right. So let's look at messages. Hey, are we going to finish the slides today? Today's class has been very interesting. Kudos to all of you who keep asking questions and contributing and interacting. That's nice. All right. So messages are how objects communicate and interact with each other, obviously. Okay. And then a message is a call from one object to another, requesting a certain operation to be what? To be performed or aiming to access what? An information. When an object receives a message, it responds by executing a method associated with what? The message. And then this is where polymorphism comes in. Polymorphism allows objects of different classes to respond differently to the same message. And that's what we call method call. Okay. So in this case, imagine you give the same instruction, prepare food, and you are giving the instruction to KFC, Pizza Man, Starbites, and which other one? Chicken Man. But the instruction is prepare food. What do you think KFC will prepare? They might end up frying chicken and then fries. Pizza Man will end up preparing pizza. What's the name? Starbites will end up probably giving you pie and then their signature pineapple ginger drink or pineapple drink. Okay. But polymorphism in this case works with standards, specific step-by-step instructions. So when, in the case of polymorphism, when you say prepare food, then that means you are referring to a specific manual or step-by-step process to guide you prepare the exact same thing it's requiring from you. That's why we say polymorphism allows objects of different classes to respond differently to the same message. Do you get it? So the instruction is what? The same, but the action performed is different. KFC is obviously preparing what? Chicken and chips. Somebody else is frying yam. Somebody else is doing what else? Is that okay? All right. So some features of objects messages include the following. You define the interactions. So the object messages must show how different parts of the system communicates. Okay. If we take KFC, for example, or a restaurant, for example, the cashier is the one who sends the message to the kitchen that okay, this customer needs this and this and this food. And then when it's done, the server now takes it. So there's some sort of interaction going on. Design behaviors, on the other hand, has to do with what an object should do specifically. Okay, the system must know what the object must do. Is it to calculate? Is it to prepare food? Is it to serve? So it has to design the behaviors of that particular object. And then in terms of enhancing modularity and decoupling, the object message is supposed to work independently without knowing the internal details. For instance, the cashier is just there to send the order, right? Prepare food. For the cashier, he or she does not know how the chef goes about preparing the food. All they have to do is to what? Just give the order and then it's done. Now, when it comes to enabling parallel development, it has to do with the different parts of the system, being built at the same time by different people. Okay. Almost like polymorphism. Okay. So one team is the cashier, is he or she's doing his work. Another team is in the kitchen doing their work. Another team is in the server area trying to serve the customer and things like that. Then we have enhancing clarity and understanding. So with the enhancing clarity and understanding, of course, the message makes systems easier to read and then understand. Because imagine you write, prepare food, and it sounds somewhere like in maybe German, and the location you are dealing with is an English-based location. How will they understand that and then keep that going? So it's a way of understanding the purpose or the internal codes you are actually using so that anybody who have access to it can understand. So object messages are basically like instructions or requests. And what they do is to help the objects communicate. It helps them define their actions. It helps them stay independent. It allows teamwork, okay? And it helps the system to understand each other, basically. All right. So in an example of polymorphism, the message good night produces different results depending on which object receives it. Okay, so in this case, we have a parent as an object, we have a dog as an object, we have a child as an object, and they have their instructions there or the kind of methods they are actually previewed to. So when somebody says good night for the parents, he or she understands it as, okay, it's time to read a bedtime story, right? The dog also understands it as maybe it's time to sleep. And then the child also understands it as it's time for me to, get ready for bed, or maybe for my mother to read me a story or something like that. Okay, so this is just to explain polymorphism. Then in this case, or in this diagram, it has to do with information system. An instructor object sends an enter grade message to an instance of the student record class. So there are two main parts of this diagram. We have the instructor and then we have the student record, right? Then between them, we have the enter grade, which is the message. So in object-oriented programming or analysis, the object is sending a particular message. Or the instructor is sending a message. Okay. So the instructor object receives the message, student record, and then the message itself, which is the method, is enter grade. So once they receive the method, the instructor knows that, okay, by entering this particular method, then this action is what will be informed or performed for it to affect student record. I think this is just explaining what the main parts of object-oriented analysis is about. The action, the sender of the message, which is the object, and then the student record. Now, an object belongs to a group or category called a class. Think of it as individual cars you see on the streets. We have Toyota Camry, we have Honda Civic, Ford, Jaguar. Is that even a car? Well, I don't really know cars like that. So,
Foxy.
oh, okay. So think of it like all these cars. Each of these individual cars is an object, right? And they all belong to the class called car. Okay. So in this case, our car class defines that all cars have attributes like color, number of doors, engine size, and all of that. It can also perform actions like, or methods like starting the engine, accelerating, brakes. So whenever you meet any of these cars we mentioned, they have similar attributes and similar words, methods. So it's almost like having an object called car, and then within the objects, or how do I, outside the objects, there is a class of cars. Okay, so I don't know if you did Venn diagram and subsets, right? So we have the class of cars as the entire Venn diagram. Within it, we have object car. Then within the object car, we have attributes of the car, we have the methods of the car. Please, do you get the idea? So when you take the class cars, they should all have similar attributes. You should be able to start the engine because they have the similar words, methods. You should be able to accelerate. You should be able to apply the brake. Okay, that's what it means. Then objects within a class can also be grouped into subclass. Okay. So when we talk about the subclass, we are looking at probably within our car class, we can have subclasses like sedan, SUV, we can have trucks. These can be subwords class. Then we also have what we call the super class, which is a class that belongs to a more general category. So in this case of cars, the super class can be what? Vehicle. Okay, so the vehicle class might define even more general attributes like the number of wheels it should have, and how it should move and all of that. And even the types of vehicle, because we have motorcycle, which is also a type of what? Vehicle. Okay. We have pragya, which is a type of vehicle. I don't know if you get what I'm trying to say. So in this case, if we are drawing a box, let me use the pen to depict what we are saying. And this is the main big box. This would be our superclass, okay? And the superclass would be what? Vehicles. Now, within this superclass, we have what? A class. And the class is what? Cars. The class is called cars. Now, within this class, we have a subclass. And this subclass are the van, the SUV, those categories of cars. Then within the same subclass, we have attributes of the cars and then the methods of the cars. Then we would have instances of these cars or vehicles. Please, do you get it? Okay, so I think this is an
Yes,
example.
madam.
So we have a class. Within the class, we have vehicle. Vehicle has its attributes and methods. We have a subclass, which is what? A car. The car. So within the subclass, we have all these the categories of cars that fall under the subclasses, and they all have attributes and words, methods, which are similar to what the entire vehicle has. Okay. So basically, that's what we had explained there. Now let's look at relationships among objects and classes. So, like I already mentioned, if you did Venn diagram, then you know what a subset is. So if we have a parent and a child, right? Which one is a subset of the other?
Child is a subset of the parent.
Sorry.
Child is a subset of the
Hey, we can't hear you.
The child is the
The
subset of
child.
the parent.
Hey, Cantamanto. Please, one at a time. What is it? What exactly is it?
The child is the subset of the parent.
Oh, okay. Do we all agree?
Yes, please.
Yes, please.
Oh, okay. So relationships enable objects to communicate and interact as they perform business functions and transactions required by what? The system. Okay. And they describe what objects need to know about each other, how objects respond to changes in other objects, and the effects of membership in classes, superclasses, and subclasses. The strongest relationship is inheritance, which enables an object called a child to derive one or more of its attributes from another object called a parent. So basically, it's telling us of how these objects communicate or interact with each other. And for us to know how well they communicate or interact with each other, there's another relationship called the inheritance. So if definitely you are your real parents' child, then you should have some traits from what? From your parents, okay? Probably you look like them, your nose looks like your mother or your auntie or something like that. Okay. So when you take this figure into consideration, we have two classes. We have the employee class and then the instructor class. So notice the label at the top, right, of the instructor. The child inherits. So everything the parent has, the child can what? Inherit it. But the child is not limited to just that. The child can have its own independent attributes as well. Okay. So for instance, let's compare. When you look at the attributes of the parents, social security number, telephone number, hire date, title, pay rate, that's for the employee. Then the attributes under child inherits are what? We have social security number, telephone number, hire date, title, pay rate, but also type of instructor. It's just trying to tell you that although the child inherits from the parents, the child also still have independent qualities or attributes that can be referred to it. So let's come back to um, a typical student's, that kind of relationship. So in this case, we might say that if we are giving an example like grade students or prepare lesson plan, you can think of it as something you are doing as a teacher or a lecturer, okay? But then once you are a lecturer in this case and you fall under parents and something else is inheriting your characteristics or features, which is your attributes, they can go beyond grade students and prepare lesson plan. They can also teach. That could be another unique attribute. So think of it like a family. Employee is like a parent. It has certain general traits and abilities that it passes to its children, of course. And then the instructor here is like a child. It inherits what? The parent's traits and abilities, but it can also have its own unique characteristics. Okay, so system analysts use the unified modeling language to describe object-oriented systems. And in this case, we use what we call a use case, which represents the steps in a specific business function. Okay, so structured programming or structured analysis uses the data flow, and then the object-oriented uses what we call the use case. And the use case uses what we call the UML symbol to describe a flow or how they represent their cases. Use case also can interact with other use cases. When a use case incorporates the outcome of another use case, the second use case uses the first case. We'll explain that shortly. Okay. So, for instance, in this example, we have patients representing an actor in the use case modeling. So, an actor is someone or something outside the system that interacts with it to achieve a goal. So, in this case, the patient is a user of the medical office system, right? And the use case represented here is this oval shape. And the oval is labeled as make appointment. That's the use case. And it is used to describe a specific goal that an actor wants to achieve by using the system. So here the patient's goal is to make an appointment with the hospital. And for you to be able to relate the actor to the use case, we make use of what we call an association. That's the arrow pointing from the patient to make appointments. Okay, so use case shows an association, and that is what indicates that the patient interacts with make appointments. So in the event you are drawing or coming up with a use case diagram to represent a system or those who interact with the system, or how the system interacts with other people in terms of relationship, inheritance, and all of that. You should think of it as having an actor, having an association, and then a use case. Okay. Okay, so this figure, when a student adds a class, produce fitness class roster uses the results of add fitness class to generate a new roster. All right, so in this case, we see two different actors. We see the first actor, which is student, the student actor. Now, when we take this particular one, we see the student associating with add fitness class. Okay. So the student initiates the add fitness class by using the case, a blue arrow, which is the association pointing from the student to the use case. Okay, and it helps us represent the student's goal of enrolling in a fitness class. So what is the goal of the students or the student actor? The goal is to be added to a fitness class. Now, in this situation, you can see that if we take this arrow out, where's my pointer? If we take this association arrow out, we will not be able to really relate, or we will not be able to really represent this use case diagram properly, because we wouldn't know what the actor wants from add fitness. So whenever you are drawing a use case diagram, kindly have it in mind that you are actually telling a story. You want to show how maybe the user interacts with a particular system. Okay. The same applies to the second instance or scenario. The second actor is an instructor. And what is the instructor doing? He's interacting or reacting or, associating with change availability. So we can see that the instructor initiates the change availability use case, and it shows the instructor's goal of updating when they are available to teach classes or not. Now, let's talk about the green dashed arrow, which is labeled users. Okay. So you can see that it's pointing from one other point to the other, or it's pointing from one other use case to the other. Okay. So this green dashed arrow with the label users is just there to update instructor information. So it suggests that when an instructor changes the availability, the system uses the update instructor to for their information purposes, so that the use case can record these changes. So the moment the instructor or the actor instructor gives an assignment to the use case, which is change availability. It is what? Updated, such that the availability of the instructor is changed, basically. Okay. So to create a use case, you start by reviewing the information that was gathered during your requirements modeling phase, okay? And the objective is to identify the actors and the functions of each actor. For you to be able to draw a use case diagram, please keep these things in mind. You need to know what every entity in that instance is doing, their function and their objectives, for you to be able to assign a proper, reference to each of them. So for each use case, you develop a use case description in the form of a table, like the one you are seeing right now. And then a use case description documents the name of the use case, you document the actor, you document the descriptions, and then step-by-step lists of the tasks and actions they are supposed to perform so that you can reference each one of them. So if we are talking about students and lecturers, and maybe the lecturers are supposed to teach, and the students are supposed to read their notes, you can't assign a use case of preparing lesson notes to the students. Do you get the idea? So that's why you have to know the function of each of these actors or these users or those creators or those who are actually performing an action within your model, and then know their functions before you assign a use case to them. Now, a use case diagram is a visual summary of several related use cases within a system or subsystem. When creating a use case diagram, the first step is identifying the system boundary represented by a rectangle. So the system boundary shows what is included in the system inside the rectangle. Anything outside the system rectangle is not to be added. So this is an example of what you are talking about. So like I mentioned earlier, supposing this figure here or this actor here were a student, and the student's role is to go for lectures. So in this case, this use case will now be students going for lectures. If the moment I represent this, or the moment this arrow is sent here, and this is maybe teach a class, then it's not represented well. So you have to know the exact function of all the users within your scope of study, or when you are gathering your requirements gathering. You should know which people will be using the system and their functions so that you can assign the correct use case to them. So this is just a use case diagram to handle work at an auto service department. Can we describe what's going on in this use case? Hello, are we here?
Yes, madam, we are here.
Okay.
You, madam.
Are we lost or we are tired?
Yeah, of course.
It's like today we did a lot of questions and answering, so our time is almost ending. All right, so basically when you look at the diagram, it's just used to present or represent the auto service department, okay? And it shows the different actors involved and the use case they interact with in order to manage work in the department. So mechanic is interacting with prepare invoice. Customer is interacting with creating work order. Service writer is interacting with prepare invoice. and is interacting with what creates work order as well. So it just shows the flow at which every user functions. So if you know the function of customer, then you can know what use case to assign to them. If you know the functions of mechanic, then you can know what to assign to them. We also have what we call the class diagram, and it shows a use cases, objects, classes, and relationships. So each class appears as a rectangle with the class name at the top. And the class diagram includes what we call cardinality, which describes how instances of one class relate to another. So this is an example of what we are saying. So examples of UML notations that indicates the nature of the relationship between instances of one class and instances of another. So we have 0 to many, 0 or more. We have one and only one, and we have one or many. These are all the nature of the relationship and how it relates to, the other instances. Okay. Then we have the class diagram this is a representation of a class diagram for a sales order, whereby they are using case, okay, to make it. So the main classes here are what? We have sales manager, sales rep, sales office, customer order, items ordered. Okay, and then the lines between them are what? The lines between them show the relationships, and the numbers like 1, 0, 1 show how many objects are involved. Okay, so a sales manager manages many what? Sales reps. Okay, but every sales rep has what? One manager. So you can see 1 to 0, 0 to 1, right? Now, when you look at the sales office is managed by what? One sales manager. So it's showing the relationship between all of this. So a sales office is managed by one sales manager. A sales rep is also what? Assigned to one sales office. Okay, and they can serve one or many what? Customers. So the sales office can serve more than one customer. And then a customer can place many orders. So look at customer order, and then items ordered. So it's just showing the relationship between them. Then we have a sequence diagram. I think we've spoken about that before, but it's a dynamic model of a use case showing the interaction among classes during a specific period. And then it has what we call a lifeline, which represents the time the objects above it can interact with the other objects in the use case. So this is an example of a sequence diagram. It shows how different objects or classes interact over time. So we have the classes, which are the actors, class 1 and class 2. They are the actors. And it represents the specific objects or system components involved in the processes. And you can see the lifeline. The lifeline are the dashes. Is it orange or red? Dash, 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 dash. So those are the lifeline. And then these lifelines represent the existence of the object over a period of time. And then you can see that there's an X mark here. So in the diagram, the X at the bottom of class 2 indicates that this object's lifeline or its involvement in this specific process has ended. That's why it has been terminated by X. And we can see the interaction, which is the messages, message 1, message 2. So the flow here or the lifeline within class 2 interacts with the lifeline within class 1 and vice versa. So the direction matters, okay? The arrow for message 1 points from the left to the right. Okay, it means that it's initiating an action or sending a data. And then you can see message 2 too. So definitely you should know that once this sends a data, message 2 is what's technically responding to that message. Then we also have what else do we have here? I think basically that's it. So the sequence diagram are just there to force us look or think of what we are working on logically. So it gives us a logic flow. Okay. So if class 2 needs information from class 1, a message must be sent first so that it helps us know that, okay, there wouldn't be any logical gap in the system when we are designing it. We also have what we call a state transition diagram, which shows how an object changes from one state to the other. Then we have activity diagrams. All these are used within the object-oriented analysis. Okay, so when you look at this particular transition diagram, it represents a diagram for a bank account. I know our time is up here, but please dash me 5 more minutes so that we finish up with this. Okay, so while a sequence diagram is showing us how the object talks to each other, like what we saw class 1 and then class 2, and how they are interacting with each other, as in message is sent to class 2 and then message is response is sent back to whatever is being done there. This particular transition diagram shows the different statuses a single object can have throughout its life. So, like I said, this is a bank account, okay? So the states here are new. So you can either have a new bank account, you can have an active or existing bank account, you can have a closed or former bank account, and then you can have what? A frozen bank account. These are the states of a bank account, okay? So each one represents a state, okay? And then we can see the transitions as well. So the transitions are the arrows that's connecting the rectangles. Okay, so the arrow shows the movement from one state to another. These happen because of specific events or triggers. Okay, so in the event that we make a first deposit, I'm sure you can see that first deposit there after new. That means there's a movement from the account from new to what? Active. Okay, so the moment you make deposits, the new account becomes active. And then in the event they attach assets, then you can either move it from active to frozen or active to closed or former accounts, depending on what is applied to it. So this is just to show us an example of a state transition diagram. And like we mentioned earlier before, when we're describing states, it's talking about the current state of how that representation looks like. So this is another activity, sequence diagram. Activity diagram or transition diagram. So in this case, an activity diagram showing the actions and events involved in withdrawing cash from an ATM. Definitely, if you want a cash from an ATM, you start by what? Needing the cash in the first place. You insert your ATM card, then the card is accepted. You enter your PIN, the PIN is accepted, then you request the amount you want. Now, when you request the amount you want, two things can happen. There is either a possibility that you have sufficient funds available. If there's sufficient funds, the ATM adjusts the balance and then the ATM provides the cash. If there is insufficient money in your ATM, the ATM will now notify you, the customer. So this is just an activity diagram showing the processes that goes on when somebody is actually placing an order at the ATM. Then object modeling requires many types of diagrams to represent the proposed system. So we've talked about use case, we've talked about sequence diagram, we've talked about transition diagram, we've talked about activity diagram. These are some of the diagrams you can use to represent your proposed system. So if this is representing an ATM, then that means definitely we have a diagram to represent what? A school. We have a diagram to represent construction. We have a diagram to represent when a flight wants to take off. Do you get it? All right. So system analysts rely on tools to speed up the process and provide an overall framework for documenting. And some of these tools are called case tools or Visio. Then we also have Cameo Systems Modeler. That's another modeling tool that you can use to actually build any of these diagrams or represent any of these diagrams. You can try your hands on it. I think that should be all for today. Thank you for dashing me extra 10 minutes. Any question, please? Any
Hello,
question, please?
Madam.
Yes. Yes.
Yes, my question is from our first week,
Yes.
we're introduced to system analysis. System analysis, yes. So I want to know the similarity or the relationship between the system analysis and the object-oriented analysis.
Oh, okay. What do you think would be the relationship? Why are we even doing objects-oriented
Exactly,
analysis,
that's what I'm trying
structured?
to understand.
Oh,
Because
so you don't,
the structured analysis was opening our eye to system development in information system.
okay.
Yeah, the requirement and the procedure, the processes. But I think from the first week till last week, we were being introduced to the system analysis, the processes. And this is our second new topic, which is the object-oriented.
Oriented
If I'm
analysis.
right, yeah. Is that so?
Not really, but if that's how you understand it, let's stick
Yes,
with
so
that.
I want to get the relationship between the two, structured analysis and analysis. Is it the same thing as the structured or there are differences?
Okay, so somebody asked a question earlier on structured. Do you remember?
No.
All right, so how do we explain for you to understand? If you understood that, it would have been easier for us to just move out of this one.
Please try and see if you explain for me to understand. However,
It's
you
not
get.
about trying and see. It actually says you were not concentrating, and it's like you're taking us back again.
No, I have been concentrating. Just that I don't get the concept of the whole course. You understand? I'm still trying to get it. So your little explanation may do me a lot.
All right. Can somebody help a brother, please? Because we spoke about this not too long ago and it's coming up again. Yes, any help? Hello. Do you remember
Hi,
when we...
madam.
Oh, okay. Yes, is somebody trying to help a brother here? The brother wants to know why we need object-oriented analysis. Is that not the question? Hello.
Yeah, I mean, the question is object-oriented analysis the same as structured analysis, or is it continuation of structured analysis? Or what is the relationship between the two? How do we juxtapose the two?
Yes. Can anybody help? Because we have said this like earlier. We had addressed this earlier. So can anybody help him or explain to him what we mentioned about that, what we said about that?
Madam, please help us.
Sorry?
Hello?
Yes.
Okay, so with structural analysis, I could say we have actors. We have something called actors. So with the actors, we can relate it with object approach, the object analysis approach, where actors could be like the objects over there, or they could also be the classes, if I'm correct.
Interesting. Do we have any other?
Hello, madam.
Yes.
Okay. Structural analysis actually emphasize on what the system does. That's the functions. And
Okay.
object-oriented analysis, the data-oriented, emphasizes on who and what the system does. Objects.
Can you come again?
Structural analysis talks
Yes.
about what the system does. That's the functionalities. Object-oriented talks about who and what the system does. That's the object.
Yeah, it's not really entirely clear, but I get where you're coming from. Okay. So let me put it this way. All the topics you are treating under systems analysis are important in their own way. So you are building a system. All the courses, all the topics we are studying about this system analysis is just to help you analyze the system, understand the problem clearly before you build the system. So how can we go about this? That's where all these individual or independent topics come into place. When you take structured analysis, you are looking at the system in terms of the processes, how data flows. Okay, what happens step by step. That's what we looked at under structured words analysis. Then when we take object-oriented analysis, we are looking at the system in terms of objects. Okay, and these objects definitely combine words, actions. And that's what we've been doing. So these are two different things. They are not the same, but they are all needed for you to understand the system better and to solve problems like clearly. Please, does that make sense?
Thank you very much. It does very well.
Okay.
Yes,
So
we
earlier,
have
when one of your colleagues asked the question, I don't know if I can quote the question verbatim. The person asked, and then we clarified that. So when you look at structured analysis, that's why we use the data flow. And then when you look at the objects oriented, it defines the objects, the classes, the blueprints, and all of that. I think we mentioned something in that order also.
Yeah, I remember.
And then I think he also asked if it supports design patterns. And we mentioned that structured analysis does not support design patterns. And because it does not have objects and classes, it doesn't use encapsulation and all of that. Anyways, any question? Any other question?
So if I understand very well, it means object-oriented and structured analysis are all needed in information system
Of course, they are.
when developing a system.
Yes.
All right.
So I think when we started this whole topic, I always tell you, depending on the type of system you are building. If we are teaching, for instance, if this is an architectural class and we are teaching you how to build, we'll teach you how to use cement to build. We'll teach you how to use clay to build. We'll teach you how to use iron rods to build. We'll teach you how to use wood to build. Do you get it?
Yeah.
You need all these individual or independent, how do we call it? You need all these independent skills to be able to build a specific or a particular system. The systems that when you're building, you don't necessarily need a data flow, but you may need a sequence diagram. There are others too. You need that data flow to represent a particular thing, and you need a sequence diagram or an activity diagram to also represent something else, and it's the same system. Please, do you get it?
Yeah, yeah. You mentioned it earlier in our lecture that when building, you will need just as you've mentioned, you will need the things that will make up the building. You keep mentioning that.
All right. Do you have any other question? Max, or your hand is up.
Yeah, madam, please, can we get any reading material like textbook?
Yes, there is a textbook. I'm sending it to your course rep right now.
Madam, it's already on the LMS.
It's on the LMS. Yes, if you read the
Yeah, even
textbooks, it's even easier to understand than your slides even. The slides just is a pictorial. We can't capture everything in the textbook in the slides. So we use the slides to explain what is in the textbook. But at the end of the day, it still does not give you the entire message. So please refer to the textbook. Is that okay?
Yes, it's okay. Thank you.
All right then. If there's no other question, thank you so much for giving me extra time. And I hope we understand what we've discussed today. All right, then we'll end the class here and we'll continue some other time. When are we meeting face to face?
on the 9th.
9th,
8th May. So May.
8th May. The level 100s are writing exams, so 8th May. Okay, they will start exams on the 22nd. When are people writing exams?
The same May.
23rd.
23rd May.
Yes.
Yeah.
1, 2, 3, 4. So you basically have 4 more weeks to go. All right then. Then enjoy the rest of your weekend.
Yeah.
Thank you.